Welcome back. In this tutorial, we will talk about some of the methods as well as built-in functions available to manipulate the data elements in a list. In a previous tutorial, we did talk about two of the methods, append as well as extend. And we also mentioned how when we invoke the method append or extend, we don't typically assign the output of this to a variable, to a different variable, because I mentioned that both methods end up returning a none type data object. Okay, so this has the effect of working directly on a list. In this case, you will add the element 4 to the list here, and the new list, the new value of x would basically have 4 elements, 1, 2, 3, 4. So this method works directly on the list. Keep that in mind. And now we're going to talk about another method. Let's talk about a method called pop, okay, where you will notice that we do have an assignment statement where the output of this method is actually assigned to a variable, in this case y. So let's look at the first statement here. This is basically assigning a list with 6 elements to the variable x. The second statement actually pops, POP pops, the element at position 1. So here's a 0, position 1. So it's basically popping the element 20 and assigning it to the variable y. So at the end of this operation, you will have a list with one less element. There won't be this element present anymore, right? And whatever that's been popped out, that's been assigned to the variable y. So that the third statement here is going to be printing the values of x and y after the pop method has been invoked. Okay, and before I run this code, I also want to introduce you to another method that's kind of similar. This is basically allowing you to remove an element. So we're not really working with an index here. Pop helps you specify the index position, the argument for this. On the other hand, for remove, we are actually specifying the element itself. So it removes the first item in the list. So for example, if this list has more than if this list has more than 150 in it somewhere, it's still going to remove the first element it comes across from left to right. Okay, so this print statement is going to basically print what happens to x after you invoke this method, as well as y. So here y is the value that comes after you invoke the method. So do you think this method is going to be returning a value that you think is meaningful? Okay, let's find out. So let's run this code. So you note here that the first method, y equal to x pop 1, ended up moving or removing this element 20 out of the list. So now the list has only 5 items instead of the original 6. And the element that was popped out, that's 20, right, which is in position 1, that is now assigned to variable y. You also note that now you take this value of x, and I said remove 50, x dot remove 50. So the first instance of 50 is going to be removed, so you don't see the value 50 in this list anymore. Okay, all right, let's try to make one small change to this code here. What happens if I remove this argument 1, right? Right now, let's look at this line that consists of the pop method. What happens if I don't specify a parameter? Okay, this is actually valid when it comes to this method. Okay, so this will actually, if you don't specify any value in there, it's basically going to pop the last element in the list. Okay, so let me make a small change to the list as well. I'm going to add a couple of elements. I'm going to type in 50, 70, and 80. Okay, so now it's a list with I think about nine data elements, and I'm not specifying a value here, right? I think it's going to pop the last element, and we'll leave it as 50, right? And we have 2 50s right now in this list. So let's see what happens. Let's rerun this code, and you note that when I run this code, pop open parenthesis, close parenthesis, has ended up popping the last element. Okay, so now this has one list element, and whatever that's been popped out is been assigned to the variable y. Okay, and when it comes to the next method, remove, right, you note that the first 50 has been removed, but the second 50 is left intact. So that's what remove does. Okay, and again, as usual, as I mentioned, assigning this to y does not really make sense because it's going to be a none value type, because whatever work that's being done by this method, it's done on the list itself. Okay, in contrast to pop, where yes, some work gets done on the list, but it does end up producing an output that's meaningful. Maybe you do want to capture the element that you remove from the list. Okay, and let's now talk about another operator here called del operator that I can use to do something similar to help me remove some of the elements from a list. So in this case, it's a del operator. Let's say that I have a list here that has 6 elements. If I say del x sub 3, I'm going to uncomment this. What do you think will happen? It's basically going to look at the third position. So it's 0, position 0, 1, 2, 3. So it's going to remove this element. Okay, and let's see if this works. So there you see the number 40 is gone. Okay, so the advantage of using del, I'm just going to comment that back, is that I can actually use it to remove multiple elements. Okay, for example, if I specify x sub 3 open and then a colon, it's basically going to say start at position 3, which is right here, to the end, remove all of them, 40, 50, and 60. So you can use the kind of arguments you can specify for a slicing operation, right, to remove multiple items from this list. So let's run this to see what happens. So you see that all the elements starting from 3 have been removed because that's what I specify here. Okay, if I say, for example, 1, 4, what do you think will happen? Let's try to run this and see. Starting at position 1, here's position 0, position 1, right, going up to 4, but not including 4. So here's your 10, 50, and 60, similar to your slicing operation. Okay, so again, a group of three things that we can do here that helps us remove elements from a list. Okay, now let's move on to some other additional methods. Okay, so we have sort and we have count. Sort basically helps you sort the elements in a list. In this case, it's going to sort the elements in ascending order. Again, note that here we have numbers, so it's easy to understand how the sorting is going to work. But if you do have, let's say, string here, the sorting will still happen, but it's going to be according to an internal logic. You know, how do you compare strings? We didn't really cover this in class, but if you're interested in it, go back, you know, and do a Google search and try to find out how Python compares strings. So for example, is apple smaller or bigger than bat? Okay, again, we won't get into this for this class, but I can use the same method to sort different elements within a list, different type of elements within a list. Okay, so now that's sort. And again, note that I'm not really assigning this to a variable because the useful work here is done on the list itself. It changes the list. Okay, so I'm not really assigning this to it. So x changes, and that's what I want. So I don't need to have an output here. Okay, and similarly here you have another example of a method. Okay, count, that basically counts how many times a specific item, in this case let's say item 5, how many times is this item in the list. Okay, and in this example, of course, it makes sense. If you count it, you don't want to lose the count. So you may want to assign this to a variable, let's say a or something like that, so that let's say that you determine there's only one occurrence of the item 5, then the value of a has to be 1. Okay, so let's try to run this code and see if both methods work according to what we think of them. So here we run this code. You can see that the list has been sorted in ascending order, And you also see that the value of A is 1 because there's only one occurrence of 5 in this list. Okay, two more useful methods. Here are some more, index and insert. So if I use the method index, so here I have a list X with a bunch of data elements here, right? If I use the index, it's basically helping me find the first item 5 in the list. So I'm specifying the item and it's going to find the first item. If it's there, first of all, it's going to give me an error if it's not there. But if it's there, it's going to basically get me the first item on the list. And here we have a list where there are 2 occurrences of 5. So it should, if this works, as we talked about it, then it should give me the index position of this 5, 0, 1, and 2. And should assign that to a variable b. And here's another example where it makes sense. Yes, you look through the list, X itself doesn't really change, but you identify the index value, index position, and you assign it to a variable b. Okay, and I'm printing b. And in case the element number 5 is not here at all, it's going to write, you're going to get an error message, right? But if you remember, we talked about try except, right? So we can actually use this exception handling to catch the error and print something meaningful. Again, I'm not going to say anything, I'm not going to provide any more detail. Again, you can do a Google search to check how the value error works. It's very similar to the discussion we had, and you will probably add this value error, when you specify except. Again, we don't need to know this for our class, but please note that sometimes these errors can be specific, and I can catch specific types of errors using the same structure. All right, so that's your index that helps you find an item, especially the first item in a list. Here's another one, that's insert. For example, what if I want to insert some element into a list? I specify the index position and I specify what I want to be inserted. In this case, I want to insert this string value, okay, at index position 2. So let's run this code and see what shakes up. All right, so if I run this, so here's the value of X with 7 elements, right? And when I say find the index of the first item 5 on the list, that should be 0, 1, and 2. Assign this to variable b, so the value of b is 2. That's what you see here. But the list itself hasn't changed much, okay? But now, this method basically is inserting this element at position 2. Position 2 is right here, right? After 3, before 5, right? 5 is currently at position 2, but now inserted is going to be in position 2, and all the other elements end up moving 1 over. That's all. So you see them here. Now they moved 1 over because I increased the size of the list by 1 with the element that I inserted, right? Of course, I can have any element I want. I can, if I want, I can say, insert 2, 50, in which case the number 50 will be inserted here. Okay, so again, 2 more useful methods for you to think about. Here we have one method where it makes sense to assign a variable to catch the value of this. Here's another method where it does not really make sense to assign the value of the output, a value of this method to y, right? So it's not really, it doesn't really return any value that's useful. Okay, so it's going to return a none type. So I don't really bother doing y equal to x dot insert because all the work is done on x itself. It's inserting this in position 2. All right, so I can also try x dot reverse, and I'm going to leave you to figure out what x does. If you want, copy this, right, and the copy x and copy x reverse and try running the code to see if you can figure out what x dot reverse does. Okay, now here are some examples of built-in functions. So far we mostly looked at methods. We looked at one operator, not really a method, but I'm just going to call it an operator. We looked at one operator in this module so far, and we mostly looked at methods thus far. Okay, so here are some examples of built-in functions: length, max, min, and sum, right? That helps you with lists. For example, if I have a list x with 4 elements, let's say, and 100, 120, 122, 143, I can use these functions on this list. For example, I have print x. I'm asking length of x, maximum value of x, sum of x, separated by new line. So print these things separated by new lines, right? So if I run this, you'll note that length tells me the length of the list, maximum simply returns the maximum value in the list, sum simply sums all of this up. Okay, so if you notice, a few classes ago or a few modules ago, we were trying to write code to find the largest element, right, in a sequence of numbers. So if you knew that list existed, that would have been as easy as me specifying max x. So very, very simple. It can be very powerful, having all these built-in functions. Again, useful to know this because let's say I can ask you, and actually I'm going to be asking you to do this later. Given a set of numbers, a list of numbers, can you compute the sum of these numbers, or can you compute the average of these numbers? Okay, so you may want to be able to write code, and you'll notice that writing code when you have a list of numbers is so much easier than starting from scratch without the use of lists. If you just had a bunch of numbers, you didn't know lists existed, doing the sum and especially doing the max and all these things would be very, very difficult. Okay, and here we have solutions to a question I asked you in an earlier module where I said, construct a list with names of 3 favorite movies. I'm basically giving you the solution to this, right? Using while loop as well as using for loop. And I also prefer, whenever possible, if you know the number of items ahead of time, always use the for loop. Okay, use while when you don't know ahead of time how many times you need to repeat. Otherwise, I prefer that you use a for loop. Okay, so I'm going to leave this code for you to figure out what it does. It's basically a solution to one of the problems I asked you to solve in a different module. Okay, and now we've learned a bunch of methods, and what I want you to do is modify a program you've already written, take a positive integer as an input from the user, construct a list containing n elements. For example, if the user says 5, if n is 5, right, then I want a list that basically is 5 elements, 1, 2, 3, 4, 5. Okay, and then I also want you to compute the average of the numbers in the list. Okay, so maybe I'll just make a small change. I want you to modify the program to compute the sum and the average of the numbers in the list. Okay, so try writing this code. It should be fairly simple, especially with some of the functions we looked at earlier. Okay, so now before I close, I just wanted to introduce you to some basic but powerful ideas with list. There is this idea, there is this facility when it comes to Python called list comprehension, where I can construct lists of numbers really easy, right? Using, let me run this example and then I can talk about how you do this, right? I'm basically constructing a list of numbers. So the way to think about this is look at this loop here. For x in range 5, so this is going to be 0, x is going to take the value of 0, 1, 2, 3, and 4, right? So five numbers. For x in range 5, I want a list that squares the x. So 0 square, 1 square, 2 square, 3 square, and 4 squared. So let me print this. So it's basically a list with squares of these x's. 0, 1, 4, 9, and 16. Okay, so it's a very fast and elegant way of generating a list of numbers. Okay, so before you run this, take a moment to see what do you think is going to happen with this code. Here we already have a list, right? And that list has a value. This is a list with 5 data elements. So what do you think is going to happen with this code? So I'm constructing another list, list 1, right? I'm taking this list for x and list. So this is going to be, x is going to be 0, 1, 4, 9, and 16. So it's going to have these 5 values. I'm basically saying construct a list that multiplies this x by 10. So if I run this code, I'm basically going to see 0, 10, 40, 90, and 160. X multiplied by 10. Okay. So this is a very powerful idea, list comprehension. You should know it. Okay. And it can also be, it can get complicated, but let's look at 1 or 2 more examples just to get a sense of, the possibilities. So here you have the expression, right? And that's what I say. Here's your syntax for list comprehension. First, you specify the expression. Then you have the for loop, right? So you have the for loop right here. And then I can even specify a condition. It's optional. In the previous 2 uses of list comprehension, we did not specify it. But if I want, I can specify it. What do we mean by this? So let's look at this by using an example, right? Let's go back to the example here. List has a value, right, with 5 elements, 0, 1, 4, 9, and 16. So here I'm doing something very similar to list 1, right? So x multiplied by 10 for x in list, but now I'm specifying a condition. I'm basically saying do this only if x equal to 9, right? So there are 5 elements, only in one case is x equal to 9. So the list should have 1 element that should be multiplied by 10. Okay, let me rerun this. The reason why the older list is printing is that I need to make sure that I print list 1. So let me run this. So now you should see a list with 1 element because there's only 1 element in the original list where this thing was satisfied. Okay. All right. Here's another example. It's it's a bit more complicated, but before you run the code, try to think through what's really happening, So here I have the expression, here I have the for loop. So what you notice that inside the for loop, instead of specifying a list or a range, right, I'm actually specifying another comprehension statement kind of thing here, right? So I have another expression, for loop, and then here's a range that can help me generate a list. So think about what the output is going to be. Okay, so this is going to generate an output, and then I'm going to use this list to generate this list, and that's going to be assigned to LST. I want to run this. Think about it before you actually see the result, right? So range 11, so 0 to 10, right? It's going to have 11 elements. Square that, okay? And then I'm basically saying take that and square that again, okay? So here's your list. So you can do the calculations, but think about what really happened here. It looks complicated, but it's actually, quite simple if you think about it carefully, okay? The last thing I want to show you before I leave, before we finish this module, is the enumerate function. Quite useful because I can use enumerate to generate both the index and the value associated with the elements of a list. Okay, what do I mean? So here you have a list. Okay, I'm actually going to make this 10, 20 list with 5 elements, 10, 20, 30, 40, and 50. Okay, now I want the index and value, right, in enumerate list, and then I'm actually doing some manipulations on it, right? I'm just going to comment this out for the time being. So let's see what happens if I just print index and value. Okay, so what's really happening is that I'm using a similar, I'm using the for loop, but I'm specifying two target variables. Kind of cool. And if I use the function enumerate, it's basically telling Python that here's a list, right? And I want to access both the index position and the value of the list. So if I run this, so I'm going to see that it's the element and the index, the element and the index position. See, and since we did not change anything here, so I have the same value for the list. Okay. Now, what happens if I did change it? If I uncomment this I'm basically taking the value and I'm squaring the value. So what do you think the output is going to be? Think about it. Okay, let's run the code. So you see that the list now has changed to squares of these original lists. Okay, in this case I chose, right, to modify the original list. Okay, so can you do this using list comprehension? Think about it. Okay, but enumerate really is useful because it allows you to access both index and value, and I can actually use this to manipulate the elements inside the for loop. Okay, so with this we stop with lists. Thank you.